Hi everybody. Here's SIG 11, which is on differential equations, right? This is the one that we were working a lot with the FRQs. A calculator is allowed for this, although I don't think you're going to need it very much. Uh, Basically, what differential equation means is you're given a derivative, right? Because for all these things, you're going to notice you start with the derivative, and they're going to ask you to do different things with that. Okay, so the first part's asking us to sketch the slope field for the given differential equation. Okay, the slope field is basically the slope at each of these points, right? And what you need to notice is that the derivative is the slope, right? So, like to find the slope at 1, 1, basically I just plug in 1 for x and 1 for y, right? And so, there's a lot of points on here. There's 16, 17, 18, 19, 20, 21, 22, there's like 23 points on here that I have to graph the slope for, right? Because not only do I have to do the ones where there's the dots, but I also need to do all these ones here. You can hardly see the dots on there, but they are there. All right, so I need to sketch all those points. There's a lot. So you want to look for patterns, right? So one thing I notice is if x is 0, right? Imagine x is 0. You can have 0 over some number, which 0 divided by some number is simply 0. So everywhere that the x coordinate is 0, we're going to have 0 slopes, with the exception when y is 0. Because what happens when y is 0? Well, when y is 0, you have some number. So if y equals 0, you have some number divided by 0, right? And that's going to be undefined, which means everywhere that y is 0, we're going to have these vertical lines like this, right? Let's quickly just go through again. Positive slopes look like this. Negative slopes go down. 0 slopes are straight across, and undefined slopes are vertical like this, right? And so at 0, 0, we're kind of having a hole, because if I plug in 0 and 0, I get 0 divided by 0, which is indeterminate form. Okay, another thing I want to notice is that if x and y are both the same number, then I'm going to get 1 or negative 1, right? So like, for example, if I plug in 1, 1, the slope is going to be 1. If I plug in 2, 2, the slope's going to be 2. If I plug in down here negative 2, well, that's going to also be 1. And negative 1, negative 1, right? Now, if I go into the fourth quadrant, if I plug in 1, negative 1, that's going to give me a negative 1 slope. So will negative 2, and those guys up there as well. And then the rest we can just do by hand. Okay, so let's do this one next. If I plug in 2, 1, right, x is 2, y is 1, that's a slope of 2, which means you need to show that it's a little bit steeper than those other ones. If I plug in 1, 2, then it's x is 1, y is 2, 1/2, which is a little bit shallower than all those other ones. Going over to this one over here in the second quadrant is negative 1, 2. Again, so it's negative 1/2 is going to look like that. And this one's going to be negative 2, which is steeper in the negative direction. To the third quadrant, negative 2 over 1 is going to give us, negative 2 over negative 1 is going to give us a positive 2 slope. And negative 1 over negative 2 is going to give us a positive 1/2 slope. Down here again, 1 over negative 2 is negative 1/2. And this one's going to be negative 2. Right, so that's the slope field for that one. Something to be aware of as well, might not happen on this SIG test, but another one, it might say sketch the curve through, I don't know, 0, 1, right? So if they ask you to sketch the curve through 0, 1, then you start on 0, 1, and you kind of let the slope push you, right? So this slope's pushing me across, this one's going to push me up, this one's going to push me up, and I go there. And I go the same way here, that pushes me up, 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 and I go there. Or, maybe another one would ask you to sketch it through, let's say, 1, negative 1, which means we'd start here instead, in which case this one would actually just take me directly to there, and I'd have to stop, and then it'd take me directly on that, because it's a straight line, right? So depending on where we start, we'd get different things here. Okay, the next one is a big part of the FRQ. Most years in the past, they've included a question like this. We want to find the particular solution. Okay, it's a very key word here. The particular solution means the solution y equals something, right? We want to get y, solve for y, find the value of c that satisfies the initial condition. Okay, the way we do this is we use separation of variables. These won't always be y's and x's. Sometimes you'll see s's and t's and all sorts of other letters. The important thing to know is that if this letter up here is y, then all the y's need to be on that side of the equation, right? Because you can't have the dy in the bottom. So the first thing we do is we separate the variables, right? So this is going to be, I need to move this y squared. So we're going to multiply both sides of this equation by y squared, right? These are going to cancel. We're going to have y squared dy. This dx I'm going to multiply on both sides, and we're going to get x to the third dx. Okay, once I have all the y's on one side, all the x's on the other side, we're going to go ahead and integrate. Integrate y squared, we get y to the third over 3. Integrate x to the third, we get x to the fourth over 4 plus c. Now, at some point, we need to plug in this initial condition. Sometimes it's easier to do it early, sometimes it's easier to do it right now. I think it's going to be easier for us right now. So what we're going to do is when I plug in 2, I should get the third root of 15, right? So that means I'm going to just put some parentheses where the x and the y are. The x is 2. When I plug in 2, I should get the third root of 15. Okay, so this, we should notice the third root of 15 cancels with that, and we get 15 over 3, which is 5. 2 to the fourth is 16 divided by 4 is 4 plus c. Therefore, c is 1. Right, so I can rewrite this equation now as y to the third over 3 equals x to the fourth over 4 plus 1, because the c value is 1. To get full points on this, you need to find the particular solution, meaning the y needs to be by itself. So let's go to multiply both sides of this equation by 3 to get rid of that 3 in the denominator. We're going to get y to the third equals 3 x to the fourth over 4 plus 3. And then I need to get rid of that third right here. So we're going to take the third root of both sides. And we're going to be left with y equals the third root of 3x to the fourth over 4 plus 3. And that's going to be our particular solution. All right. Last equation here is write the equation of the tangent line. So again, we want a tangent line through the given point. Remember, the overall idea of a tangent line is a line. Y minus y1 equals mx minus x1, where x1, y1 is a point and m is the slope. They basically give us, here's x1, here's y1, right? So they're giving us those. And we need to find m. Well, m is simply the slope. The slope where? Well, the slope at 1, 1. So they give us this function. In this case, it should be t's because we're working with the t variable instead of x, but it's not a huge deal. So we're going to plug in 1 for y and 1 for t. And we're going to get 1 over 1, which is 1. So the slope is 1. And this is the equation of the tangent line through that point. All right, so it's almost easier than the other ones because they give you the derivative already. You don't have to take the derivative to find the slope. It's already given to you. And they give you that other point as well. Okay, so I hope this is helpful, and good luck.